Okay, to conclude our look at frequency distributions and to get into graphing, I'm going to create some graphs out of this data that we've just been using. And I'm going to do this by hand, and we will move more into technology at the end of this module. But what we want to do is to realize that if I'm going to make a graph, I want to define some axes. And so for what we're going to do here, I'm going to define these axes here for us. And what they're going to be is they're going to represent the frequency, or how often, the count, and then the bottom is our variable of interest, which in our case was the money spent on out-of-pocket prescription costs, dollars. Now what we have to do is we're going to need to deal with the gap that we have in our data. So if we would come back up here and look, our classes have a gap of 1. To get from 190 to 191, we have a gap of 1. So what we're going to do is we're going to take that gap of 1 and we're going to put one part of it in front, 194.5. And one part at the end, and so 190.5. So notice that gap of 1, I put half of it before and half of it after the first class boundary. Come up here and look at this again. Half of it before is 154.5, half after is 190.5. And then in my next boundary, so this would be 190.5 to 226.5. I'm just going to keep moving up here. And then 262.5. And of course, if I were doing this on paper, not on a computer screen, I would use graph paper. Last one, I think it's 406.5. I think I wrote that wrong. Yeah, 406.5. My apologies. What I've done is I've made a bin visually across the number line for each piece of data here. And what I'm going to do, I'm going to go, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And so now I've taken space and I've laid out my space so that I can count how many things fall into each bin. Let me change colors here for a bit. And so if we look at the table up above, I had 3 things in the first bin. So to visually let that be represented here, I come over to 3. And I put 3 in there. Let me see if I can color this in. Let me try to color that in. Oh, no, that colored everything in. Bad job. That's trying to be a little fancier than I should be. Let's try that. Just to get the visual representation here. Nope. Oh, I'll try one more way of doing this. I'll come over to 3, over and down, and fill that in. There we go. And so that represents the frequency for the first bin. Well, I can repeat that. If you look at the data coming through, my next bin had 2. So I'll come over to 2. Come in here. I'll fill that in. And I will keep, what was my next bin? I had 5. I'll go up to 5 here. And then I had 6. And then 7. So I'll draw a line of 7. This is much more fun here on a blackboard in the classroom where I have to, take tons of pieces of chalk to do this. And this technology makes it a little easier for me to draw things quickly. And as you have noticed, my handwriting is not the cleanest. And then in 3 in the last bin. And so what I've done is I've made little markers that mark how much stuff is in each bin. Now, I'm going to use these markers to explain some of the rules, and this is called a histogram. The thing about histograms is they should always touch. There should be no gaps. That's why I put the 0.5 in between these. I wanted to make sure that there are no gaps in the histograms. And we'll find when we move to things that are discrete values, that will help us deal with the decimalization that happens. We'll have our boundary. And so we now have a visual representation of the out-of-pocket expense. And this visual representation should tell us something here. The top bar tells us how many things each bin has. And we can see, when I said before, when I looked at it, I said most of the stuff was in these 3 bins. We can see there's a bump here. And this bump contains most of the things. And we'll find that the area that I had to paint for a bin kind of works like a percentage. But visually, this is telling me most of your stuff, most of my stuff is right here. And so we're letting the visual show me where the data is. And so this is called a histogram. And so the rule for a histogram is that you have the bins so that they're touching. That means you have to close the gap that's in the bin. And in our case, we added 0.5 to the beginning and 0.5 to the end. Then you mark off the frequency and you color in everything underneath that for the bin. And you now get a visual representation of your data. And histograms are very, very useful ways to look at data. Now there's 2 ways these get labeled. Sometimes they get labeled with the boundaries. Other times they'll get labeled with the midpoints. So I'll label the midpoints in here in red to show the difference between the boundaries. So that's 172.5. Now this would normally be underneath 208.5, 244.5. Remember we did all the midpoints earlier. 280.5, 316.5, 352.5, and 388.5. And you can have an either or. And it really depends on what you want to talk about. A lot of times for reporting data, it's good to have the midpoints. You'll see that the midpoints are a good way for us to pull information back out. I personally, the type of data I do, I use the boundaries. And the shape now tells us what we want to look for. It tells us where most things are, and we can see that in here and above has more than 2/3 of our stuff. It's filled with more things. And histograms are probably the most used graphical thing within statistics. You get used to reading these and knowing where your data is and what is there for data. Another way of getting the same information but focusing on how it changes is called a polygon. And what happens with the polygon is you start with your 0, and you move to the midpoint with a dot. So I'm going to do my polygon over top of what's here. And so I'm going to put a dot on the midpoint. So pretend this histogram is not there. And this is how you create a polygon. And what you want to do is you want to go one more class width over to take up for, and so I'm going to put another class width over here. And so we go down 36 from this will give us 136.5. And we go up 36 from here, this will give us 388.5. Oops, we're coming one class width from the midpoint, that's 136.5. Come up one class width from here, so it's 388.5 plus 36 is 420. Let's see. 420, where's my calculator? 424.5. There we go. Sorry about that. And so these are new midpoints. And what we do with a polygon is we connect the dots. I'll do this. There's that dot. There's that dot. And what we're going to be doing with polygons and the connecting of the dots is it now tells us how the data changes. Again, just seeing the polygon with all of the histogram not there, it tells me how quickly I go from my 0 point to the first piece of data. And the thing we can borrow is from lines. Lines have things called slopes. And the slope of the line tells me how my data changes. And so slopes talk about change. And if I move from left to right, slopes that go up increase. And then moving from left to right, slopes that go down decrease. And so this tells me, looking at this, that this increases, and then decreases, then increases again, until I get to this value, around 316.5, and then it's all decreasing. And the steeper the line is, the quicker it increases or decreases. Okay? So the lines like that increase and decrease really quickly, while lines like this increase and decrease really slowly. And so by visually putting the polygon in there, I can start talking about how my data is changing from one value to another. Now I'm going to keep this up here because what I'm doing, and if you go through the slides and you go through your reading in your book, all of this information is still on the same data, and there's different ways of looking at it. And we can pull out different graphs. So if I look just at the polygon on its own, let me get to my polygon on its own. There we go. Come over here, and there's the polygon on its own. Right? And so you can see the shape there. Now just put it still gives the same information, but by changing what we look at, we focus a little bit more on what we want to see. And in this case, it's how the data is changing. Well, another thing we can look at is what's called relative frequency. And remember we had those relative frequencies where I looked at how much the percent of things were in there? What's really nice about relative frequencies is I can make them really quick. If I've already made my histogram with frequencies, I can turn it into a relative frequency if I delete my scale over here. And let me get a bigger pen. There we go. Oh. I'll erase the scale over here. So what I'm going to talk about now is the relative frequency. And because I was counting things up on this side before, but now I'm not going to count. I'm going to just do percentages. And so, well, this was at 10%. I don't have one of my colors here. Let's try it again. Uh-oh. That. There we go. This was at 10%. That's at 20%. There's 30%. And I can now do a relative frequency just by changing the scale over here. And I can talk about percentages. And we'll find when we talk about populations, talking about the percentage of things are extremely important. And so this becomes our main tools, our histograms and polygons. You'll find most of the work we do will use histograms. And there's one last thing that I can do here, and I'm going to draw another graph, which again looks at how things change. You know, I think what I'm going to do is I'm going to jump over to the actual graph down here. Let me pull this over and just show you the answer, so to speak. And what we're looking at is what's called a cumulative frequency. And so if I make a dot for the cumulative frequency, or every piece of data that went out, I get this. So I start with the first midpoint and I work my way through. And what this tells me is where I'm at in the overall total. And so as cumulative frequencies go, they always rise because I get more and more stuff. And how steeply it rises is telling me how much stuff came within that gap. And these cumulative frequencies get a special name. They're called ogives. And they'll be useful for us for figuring out where things are. And we get this a lot of times. We'll talk about percentiles and cumulative frequencies. And so this covers relative frequencies and their graphs. This is section 1 of the chapter. We're going to look a little more at some graphs in section 2, and it's some different types of graphs. And then we're going to try to figure out where the middle of our data is. We've already hinted at it visually, that when we look at our data, there's a place where 50% of the stuff is here, and there's a middle where 50% of the stuff is on one side and 50% is on the other. And that middle might have meaning for our data. So our goal is to get visual things that help us take what started out as a list of jumbled numbers. Right? When we started with this data, before we built the distribution, we just had a list of jumbled numbers, and now we're putting it into places where we can look for patterns. And the pattern we're looking for is, where is all this stuff? And does that stuff have meaning? And so the meaning that you'd want to say that came out of this was, well, you know what? If I were going to randomly pick someone out of the population, I'd say there's a pretty strong chance that they're going to pay around $316.50 out of pocket for their prescription drugs. Now, we're going to find more ways to make that statement better. And that's a lot of what descriptive statistics is looking at this and saying, hey, if I pick out of here randomly, odds are, chances are, that's where I'm going to end up, somewhere in there. And really somewhere in here seems to be where our chances get us. And so we're going to use visual clues and graphs to do that, and we're going to use numbers to do that. So I'm going to stop this video, we'll do some more graphing stuff, and then we'll get into some more calculating. But you really want to practice these frequency distributions. They're an important way of reorganizing your data so that you can find pattern out of it.